Hello, I'm Steve Sylvia, a full-stack developer on the ArcGIS StoryMaps team. In today's session, we'll talk about how our team rebuilt ArcGIS StoryMaps from the ground up and what it takes to engineer a large web application like ours. Feel free to follow along on screen with the URL provided, esriurl.com/storymaps-devsummit. If you're unfamiliar with our application, ArcGIS StoryMaps is a publishing platform that sits on top of ArcGIS Online as well as ArcGIS Enterprise that enables you to create and share stories which inform, inspire, and engage the world around you. We completely rebuilt the application from the ground up about 2 years ago from a collection of simple templates into a single, fully integrated builder that allows you to mix and match different story types. All of our stories can be created with a beautiful design without any developer or design experience. If you've ever seen an iceberg, you may know that only about 10% of the ice is visible above the water's surface. The rest is hidden out of sight. In the same way, we strive to make ArcGIS StoryMaps a beautiful product that is easy and even fun to use. But it requires a lot of planning, design, and engineering that is not always visible at first glance. In today's presentation, we want to dive beneath the surface and give you an in-depth look at what it takes to build an application like ours. Some of the topics we'll cover today include the general architecture of our application, both the backend and front end, the main front end framework that we use, React, and how we use it, some of the specific frameworks and processes that we use with React, as well as how our team integrates with ArcGIS Online mapping and the JavaScript API. And finally, we'll finish off with a look at our deployment and scaling infrastructure. While this session will be fairly technical in nature, we'll not be walking through specific code demos. Instead, we'll mainly focus on high-level architecture and the patterns and practices that have made our team successful. We believe developers of all levels will find this information informative as they relate it to their daily work. So with that, I'll hand it over to Pong, who will give us an in-depth look at the general architecture of our application.
Thanks, Steven, for that wonderful overview. And hello, everyone. My name is Peng Wang, and I am a full-stack web developer here in Esri. And today in this section, I'm going to talk about general architecture in ArcGIS StoryMaps. First of all, let's take a look at the main components. We have 3 main components. For the front end, we have the isomorphic web app written in React and Next.js. And for the backend, we have the StoryMaps server, which is written in Node.js and Express.js. And it is also running Next.js and it is mainly responsible for server-side rendering. And we also have the ArcGIS Online/ArcGIS Enterprise, and you can think it as a cloud-based service. We use that for authentication and file storage and also as a database. And we connect to it through the REST API. Let's talk about the front-end app. I will talk about what is an isomorphic web app, how it works, and why we choose it. First of all, an isomorphic web app means the web app is capable of running on both server-side for server-side rendering and on client-side as a single-page application. The way it works is illustrated in this diagram. First, the user will make a request to page 1 from their browser. Then the request will first reach the server. The server will run the web app on server side and return the rendered HTML page with all the keywords from the story as meta tags. Once the browser receives the HTML page, the user will be able to view it immediately. Then the page will render again at the client side and become interactive, and it works as a single-page application from this point. And also, after this, any subsequent request to the website will be handled at client side. For example, if the user requests another page 2, then the client will only request the missing assets like JS files and CSS files from the server. And once the client receives all the files, it will simply render the page again at the client side. The reason we choose this is because server-side rendering is good for search engine optimization. This is useful to make the story we created discoverable. Imagine when a user make a request to view a story, the server-side rendering will return a HTML page with all the keywords from that story. This way, the story will become indexable and searchable when other people search for related keywords. Let's take a look at the backend components and how they work together. As mentioned before, we have two main backend components: StoryMaps server, which is mainly for server-side rendering, and ArcGIS Online, which is mainly used for storage and authentication in StoryMaps. How they work together is illustrated in the diagram. When a user makes a request to view a story, the request will first reach the StoryMaps server. Then, as part of the server-side rendering process, the server will run the web app on server side. While running at server side, the web app will work similarly when it is running at client side. It will run the React app going through all the lifecycle methods, like a constructor and render. And during this process, the web app will do authentication, request page data from ArcGIS Online through the REST API. And it will also parse the request and determine the user's locale and fetch the corresponding locale string from server and add it to the page. Once the web app finishes rendering, the StoryMaps server will return the rendered page to browser. Next, I'm going to talk about a challenge we had while architecting the website. Since the new story map is great, we got the requests from enterprise users to bring the latest story maps to ArcGIS Enterprise. However, since there are security concerns about Node.js server, we can't add Node.js server into ArcGIS Enterprise. In other words, we have to make the story maps capable of running as a complete static site with no server-side rendering. This is actually hard since we are relying on the server for a bunch of critical tasks during the server-side rendering process, like showed in the diagram on the left side. We are doing routing, authentication, parsing user locale, and fetching strings on the server side. However, to bring story maps to enterprise, we have to make it work in complete static mode like a single-page application, which is, when the user makes a request, the app should figure out what assets it needs, and then request those assets from the server and render the page only at the client side, and we cannot rely on any server for all the things mentioned above. Of course, it would be doable if we just start from scratch and write a static version of story maps, but the cost to rewrite is huge, and we will need to maintain two versions of the same app, which is not a good thing to do. So, the goal here is we need to find a way to make the app work in both server mode and static mode with minimal code change and maintenance in the future. This is a hard task, but we are also excellent engineers that are always looking for a challenge. So we spend some time and explore solutions that can achieve this goal. Next.js offered an interesting option, static export. The image on the right side is showing how it works. We just need to specify which page to export in the next config file and run the next export command. Next.js will pre-render the specified page into HTML, so next time when anyone requests that page, the server can just send the rendered page, and once it reaches the browser, the page will render again to become interactive. However, the problem with this approach is also obvious. It is only intended to export page with fixed URL. As you can see from the config image, it is used to export certain posts with fixed queries rather than a page that can handle any post query. And on top of that, it still can't offer things we do on the server side, like routing, authentication, request data, and fetch locale strings. However, if you are familiar with how single-page application works, adding a client-side router will become a good option and probably the solution to this problem. As mentioned before, whenever the page is exported and sent to the client side, the page will render again to become interactive. Imagine at this point, we only load the router page with a simple loading icon, and behind scenes, the page can mount the correct page component depending on the URL, and make all the necessary network requests to do authentication, requesting story data, and fetching locale string. After everything is ready, we can simply re-render the page to remove the loading icon and show the actual page content. To summarize, in the app, we just need a flag to tell if the app is running in server mode or static mode, a client-side router to provide routing for static app, and some methods in React lifecycle to prepare page data like authentication data, story data, and locale string during the rendering process. And this way, we actually make the StoryMaps website capable of running in both server mode and static mode with minimal code change. These are all the topics I want to share with you for general architecture of ArcGIS StoryMaps. Next, my colleague Steven will talk about React and how we use it in StoryMaps.
Hi, my name is Steven Kitterman. I'm a front-end developer on the StoryMaps team. So Peng has detailed the architecture of our application, and he mentioned that we use React.js. So I'm going to talk about why we use React and how we use it. So why do we use React? Well, for starters, React has a unidirectional data flow. Data flows from the top into a component and out as UI. And this makes the application a little bit easier to reason about. So on the diagram on the left, we'll notice that React treats user interface as a function of state. The idea is that you give the component some data and out comes some UI. And this is fairly simple to reason about. Another underlying principle of React is based on components. So a component is the fundamental unit of React. The component can be reused and often is, as well as that it is independent and encapsulated. And so this makes it easy to compose a large user interface with components that individually are fairly simple. Another selling point with React is that the API is fairly small. There are not a ton of React-specific concepts that you need to know in order to get started. With hooks, this has changed a little bit, but in general, React still has a fairly small API surface. A benefit for us is that the developer community behind React and that uses React is very large. So for things like troubleshooting when there are questions or issues, as well as finding third-party libraries, and also for onboarding and hiring developers, all of this is made simpler by having a larger community of developers that use React. For our application specifically, React has been very beneficial because it only handles the view. Now, as Peng detailed with the architecture, our architecture is catered to the needs of our product. And one reason we chose React is because it gives us the architectural freedom to do what we need to do without fighting the framework, because React only deals with the view. And at the time that we were selecting frameworks, we, of course, needed a framework that had server-side rendering support for things like search engine optimization, and React offered this support. So we've talked about why we use React for our code base. Now let's talk about how we use it. So our code base has somewhere around 900 components, so a reasonably large application. And we manage these and group these into packages. So we have a mono repo that we manage with Lerna, and then we split out this repository into multiple different packages. So we're able to split out the components into, say, a package for reusable component primitives like buttons, drop-downs, inputs. We have a package for UI that's specific to the story builder and viewer, which is what you're seeing here, and a package for top-level components, things like our pages or headers. And we're able to keep all of these inside the same repository. Another thing that we do is we group the readmes, test files, and any other files that are related to a component in the same folder with it. And that just makes it easier to keep all of the component concerns together. Let's look at some practices and patterns that we use with React. Currently, our React components are a mix of class and function components. With the advent of React hooks, most of our new components are written as function components, even if they're stateful. But in keeping with React guidelines, we've not gone back and tried to rewrite all of our class components as function components. And in practice, having this mix of class and function components hasn't been too big of an issue for us. We aim to keep our components small, and we also aim to render children when there's a component that composes other components. So for example, if we have a page container, we don't have a property called page content that we render in a specific spot. What we do is the page container can take in children that it can render opaquely. So it makes the component a little bit more flexible and future-proof. Now, those of you who are React devs are probably wondering how we manage state, as there are many ways to manage state with a React application. In general, we co-locate the state with the component where it's used. And if there is global state that's needed in many different components, we use React context. So shown here on the left is a simplified diagram of some components in our application and how they work together. You'll notice that we have a top-level app component that renders a page. A page, in turn, has a header and a content list components. If we look at this content list component, we'll notice that it has state as items. So this is state that's local to this component. The content list, for the sake of example, could fetch some items from a server and render them. And so keeping that state local makes sense. Over here in the header, however, we need the user session, and we'll take this in as a property. But of course, the user session is something we may need to access in many places in the application. And so what we do is we provide the user session at the very top level component to the user context, and then any component can subscribe to this context in order to receive it as a property. And we use higher order components for our class components and hooks for our function components to consume this context. Our application is for everyone, and so it's important to us to support a worldwide audience. The application is translated into 38 languages, and this includes things like making sure that dates are formatted in a way that makes sense to users. Also, making sure that the directionality is correct. Of course, some languages are directioned from right to left, and it's important to know which UI elements to flip and which ones not to. We use a library called React Intel that helps us to internationalize our application and also format things like numbers and dates. Let's look at an example of how we apply some of the principles that we've discussed so far on a slightly modified version of a component that we use in our application. If you have published a story, you've probably seen our loading screen. And so this is a component that we have many places in our application. It's reusable. You'll notice if you look closely that we are using TypeScript. We find TypeScript to be helpful. For us, it helps us to detect bugs, makes refactoring a little bit easier because if you change a property or change a type, TypeScript will let you know if there's an issue. You'll notice that we are importing from React and also some app logo component, but also from the StoryMaps-components package. And in reality, this is actually part of our code as well, but it's just in a different package in our monorepo. If we go down, we'll notice that we are creating a loading screen component, and then we have a hook that we wrap around some of the functionality in the React Intel library. And this enables us to be able to pass a string ID, and then we get at runtime the actual translated string. Also, we have variables that we use to enforce consistency across our application for things like spacing, vertical rhythm, colors, font sizes. And our loading screen we expect to take in a message, which we render in a specific HTML tag. But as mentioned before, we also can take in children. This loading screen may wish to display a logo or an icon or additional UI that the user can interact with. And so we keep this flexible and future-proof by by rendering it this way. We also style our components in the component file itself. I won't go into details of our styling solution. Steve Sylvia will talk about that in the next section. So React has worked very well for us, but of course that doesn't mean that there haven't been challenges and issues. One of the main ones that we've encountered recently is that when we started using React hooks, we ran into issues with the useEffects dependencies array. So the effect hook has an array of dependencies, and any props that are used inside the effect should be put in the dependencies array as well, so that the hook doesn't get stale. Well, there's linting rules that help enforce this, but they actually add the prop to the dependencies array. So this means that not only are you formatting your code on save, you're actually changing the behavior. And this was not intended, and sometimes was a bit of a surprise. So in places where this was a problem, we have had to disable the rule in line. Having a monorepo has been helpful, but it does make managing third-party dependencies a bit more cumbersome, because you can now have each specific package with its own dependencies. So it can take a little bit more time to make sure that the dependencies are correct. React also has the potential for using more HTML. Because components are encapsulated and isolated by design, you're not reaching into other components to look at their UI or querying the DOM very often. It can mean that it's a little harder to reuse HTML elements. And last of all, we have a large development team, about 12 developers, and so it's important for us to maintain consistency in the code. And we're able to facilitate this by code reviews as well as having good documentation. We try to put a README at each component that we put in the folder right next to the component file itself, so that it's easy as a developer who's new to a component to quickly learn about it, reasons behind why certain things were done, or perhaps how it should be used. And so, of course, any technology choice comes with trade-offs, but overall we've been happy with using React as a front-end framework. And now I'll turn it over to Steve Sylvia, who's going to talk about tooling and processes.
Thanks, Stephen. As you've heard, we're very happy with React as our front-end library, but there's a couple additional libraries and frameworks that make us very efficient as a team. I also want to talk about our process called design-driven development that helps us bring new features to ArcGIS StoryMaps even quicker. First up, let's touch on Next.js. Next.js is a framework built on Node.js and React that provides a really nice developer experience and removes many of the complexities that are required to create a server-side rendered application. Routing is extremely easy. All you have to do is add a new React component under the pages directory and everything just works. The first time you hit a page, the route is rendered by the server. Each additional link or route is handled client-side. JavaScript bundles are prefetched and it works exactly like a single page application. The very nice thing about this is it's a smaller load on our server. Next.js also has very flexible hosting strategies. As Peng mentioned, our application is hosted in several different areas. ArcGIS Enterprise uses a static export that runs completely without a server and just served via static files. But our hosted version on ArcGIS Online includes a full server-side rendered application isomorphic version. And Next.js is one of the few frameworks that work with React that provide both at the same time. It also includes strategies for optimizing caching and how to do easy data fetching that work on the server and the client in the same way. Beyond this, Next.js has a fully managed build system. One of the benefits of using a framework like Create React App or Next.js is the build system and all the optimizations that integrate tightly within the React library are handled for you by a dedicated team of developers, plus many open source contributors working to maintain the build system itself, improve performance with the web changes, and upgrade as changes to the React ecosystem come. Next.js has many core contributors from the React team, as well as Google Chrome browser and more. Beyond just these simple things, Next.js has many other great features that you should take a look at, including internationalization routing, image optimization, and more. For our style system, we use Style.jsx. Style.jsx is an extremely fast CSS and JS library, as most of the optimizations are happening at build time. It's also tightly integrated with Next.js. It was started by the same company, and in fact, many of the core contributors work on both Style.jsx and Next.js. One of the reasons that drove us to use Style.jsx was its easy onboarding. If you know how to write plain CSS, and you know how to write template literals from ES6, you can easily get started creating dynamic styles. It also has very good support for theming components, and you see this used in our application as we theme our website, as well as theme our stories with the same components. One of the big benefits of using a CSS and JS library is that all styles are scoped to the components that are using them. This is very similar to the upcoming Shadow DOM specification by the browser. It helps prevent bugs because styles do not leak from one component to another, and it allows you to use very simple selectors to style your components, which allows you to easily override as you need to. One of the big benefits to using a CSS and JS library over traditional CSS is how easy it works with server-side rendering. Just put the styles you want on the React component, and when those React components get rendered by the server, only the styles you need for that first render will get sent to the client. As new components are rendered on the screen by React, only those new styles are added. Previous styles get removed as needed as well. Now let's look at our development process called design-driven development. Design-driven development is a design-first approach and includes a short feedback loop because all designs are tested during the design phase. Designers do not have to wait for prototypes to happen. All usability testing can happen early to make sure customer requirements are met and that features are easy to navigate. There's new tools available that allows designers to create complex mockups and even have animation and workflow processes tested early on. In this design-first approach, design influences architecture instead of the other way around. This ensures that all new features are lovely and easy to use, but all still function as needed to. This does not mean developers do not have a say. In fact, all designs have a technical review before they are marked as done. So once a design is marked as complete and ready for developers, now comes the design handoff. What's included in this design handoff? First and foremost, high-fidelity mockups. Each developer knows exactly what's required of them, down to full CSS specification. We also include business rules, strings, and other design notes that help the developer know how to effectively manage the feature and how it should respond to different applications. It includes user flow diagrams and responsive designs so the developer knows how to create a smartphone display, a tablet display, and desktop display. If there's any animations or transitions, all those are documented with simple videos that the developer can replicate. Finally, some of our features are very large and expected to grow over time. We can't release a complex feature all at once, so we document how that feature will grow and enhance over time. This helps the developer know how to architect the feature to be flexible enough to handle feature enhancements. One of the patterns that we use on our team to speed up development is a component library. It allows us to reuse code and design components across our application. There's also several other benefits. First, it's very low investment cost. The first time you need a button component, just create a button component. Every subsequent time you need a button component, instead of recreating it, just reuse the one you already have. This also makes it very easy to onboard new developers. Developers can see what good development documentation looks like in small, isolated chunks. It's also easy for them to adopt patterns that are used on the team in their own components. Beyond that, it also lowers the cost of maintenance and prevents bugs. If design changes, as it inevitably will, you can make the change in one place and every other place that uses that component automatically gets the design change and improvements. It improves performance because you don't have code for every single button in a different place. You only have it rendered and parsed one time when it's sent to the client. It also helps you create a consistent design across your application and ensures that branding guidelines are followed. A couple tips I have for you when you're creating your own component library. First and foremost, develop in isolation. If you develop your component in the first application it's being used, most likely your component will look different than if you've thought about it in a reusable fashion. Also, create clear, concise documentation. This includes things like sample usages and different variants. Also, make sure you provide in-code comments that would be very helpful for different developers, as many developers may work on the same component over time. It's important to know why decisions were made and how those decisions affect the component overall. Also, don't try to over-engineer your component from the beginning. Design requirements will inevitably change, and this may require you to add new components, new features, or different configurations that don't match your initial properties that you've set on your components. Last but not least, ensure your component has hooks for accessibility and internationalization. You're creating a website for everyone, including those with disabilities and those from different languages. Ensure your component is flexible enough to handle the things it needs for accessibility, such as ARIA labels, tab focus events, and more. Also, ensure that you have enough places to put different strings and maybe strings for different usages, such as buttons. One of the tools that we use on our team to build our component library is Storybook Js. It allows us to build our components in isolation with hot reload. It also allows us to showcase multiple options and multiple variants of our components with the simple click of a button. Beyond that, it includes plugins for testing accessibility, as well as internationalization without having to leave the environment. Finally, it includes documentation. Oftentimes, a developer is working on a component they didn't initially create, and having documentation available right away is also key to success. So with that, I want to hand it over to Yang Quan, who will give us an introduction to how our team uses the ArcGIS Online mapping platform and the ArcGIS JavaScript API.
Thanks, Stephen. My name is Yanquan Zhang, and I'm a front-end developer on StoryMaps team. In this section, we'd like to share some tips and tricks in 3 aspects that we learned while working with maps in our product: how we use mapping in React, how we handle map performance, and how we style maps. On the left is a copen where we render a map with customized styling in the React app. Let's see how we can achieve this. In the React app, we use the library Azure Loader to load the ArcGIS API for JavaScript, or JS API for short. If you love TypeScript like us, please check out this link to see how to include tabs for the API. In the code snippet on the left is how we can use the Azure Loader library to load the corresponding modules from the JS API in the function component. This component renders a div element that is referenced by the map container ref, and the map view instance is referenced by the map view ref. We're going to come back to these variables in the next slide. There are a couple of things to notice here. First, let's look at line 23. In case you need to work with a different version of the JS API other than the latest official one, you can call setDefaultOption to specify it. Then let's look at the main logic of loading the map using the Azure Loader, the function loadMap, on line 3. It first loads the CSS to style the map elements. Meanwhile, it loads the modules, and finally, it creates the map view. So the next question is, when are we supposed to call this function? Let's look at line 17. We don't load the map until the DOM node is ready for us to consume. That's why we need the use effect with the empty dependency list. We also want to destroy the map instance when we return from the use effect. We're not including the destroy step in this sample, so we can focus on the main logic, but we'll come back to this in the next slide. Before we move on to the next slide, let's take a quick look on line 8. As you see, you don't have to load the Esri map module to create the map instance. Instead, all you need to do is provide a plain JSON, and the JS API will auto-cast it for you. So now you can write a cleaner code, but be careful. You may have to explain what it is to TypeScript. Now let's talk about performance. The JS API mainly targets the scenarios of single map apps, but in our product, StoryMaps, to better tell a story, the users most of the time probably need more than one map. So there's a performance concern, right? What we have been doing is to utilize Intersection Observer API to lazy load and greedy unload maps. Lazy load is to not create a map until needed, and greedy unload is to aggressively unload the map once it's no longer in the viewport. Let's look at the code snippet. Please note that these variables are the ones we just talked about in the previous slide. The trick to unload the map is to set view container to null, and once we need the map again, we set the view container back. And don't forget to destroy the view if it's no longer needed, for example, when the component is going to be unmounted. And the way to properly destroy the instance is to call mapView.destroy. Last but not least, we also need to style the maps in a way that they are consistent with the look and feel of the rest of the UI. What we do is apply CSS overrides to targeted elements rendered by the JS API, globally but still in a scoped fashion. As my colleague Steven just mentioned, we use style.jsx. This allows us organizing the overriding CSS into specific styler components. Here's an example on the left. The component returns nothing but the style tag powered by the style.jsx. In order to scope the styles, we pass in a selector prop from the parent. Imagine in your app, you have nicely defined color palettes, and they are available from your theme context hook. Components like this will be the exclusive place where you connect the theme variables to the map DOM elements. One tip here is that you really want to make sure the CSS coming from the JS API is overridable, not only specificity-wise by including more specific selectors, but also, for example, for loading the right font files in case you have your own font files that happen to be used by the JS API CSS. To resolve issues like this, you may want to call the load CSS with this second parameter so that the JS API CSS link tag will be inserted before your own style tags in the HTML, especially when the insertion happens later in the app lifecycle, because remember, we can always lazy load the map as well as the CSS. We know we can barely scratch the surface of map-related development, but still, hope these tips and tricks can possibly save you some time in your own projects. So now, I'm going to hand it over to my colleague Aniket to talk about deployment and the scaling in our product. Thanks.
Thanks, Kwan and others for the detailed overview of the software stack. This is Aniket Vani and I am DevOps lead for StoryMaps. Let's look at how we do deployments and releases for large-scale web applications. Before we jump into the details, let's see StoryMaps in numbers. This will give you some perspective on the scale of our operations. Last year, we served a couple of billions of requests from our infrastructure, and that too with the average response time of 0.5 seconds. As story goes viral, we get sudden bursts of traffic. Last year, one of the biggest daily spike was 32 times of the average. Our architecture handled such spike in traffic without any manual intervention. In terms of releases, we did 20 releases in last year. The backbone of our release process is our CDCI pipeline, which did almost 1,500 builds and thousands of PR checks last year. One thing I would like to highlight is, with all the challenges that year 2020 presented us with, we had no downtime for the StoryMaps website. Efficient CDCI pipeline is crucial for team success. Each of our PR goes through the PR checks, then it goes through the code review process, and once merged, code gets deployed to the dev environment. This helps us identify any potential issues sooner. As we come close to feature completion, we move the code to QA environment. Once deployed to QA environment, It goes through various tests like functional automated test, manual regression test, and internationalization test. If all of these tests pass, then we release that code to production on the release day. It is possible to do all of this work every 2 weeks since we have invested in unit test and automated functional test. On the surface, you might feel unit test or functional automated test are time consuming and difficult to maintain. But in long run, they prove beneficial and give good return on investment. Even though all the builds are automated, our production build needs manual oversight as a safety feature. As I mentioned earlier, we release a product every 2 weeks. This short release cycle enabled us to share features sooner with our users, get feedback quickly, and adjust our roadmap accordingly. Bi-weekly releases are loved by our users. This is not just good for users, but team members also get better flexibility and in turn, they feel more motivated to work on releases compared to normal date-based or longer release cycles. Switching to bi-weekly releases was a huge logistical challenge. We have to rethink everything. How we will do our PRs, how we will do UAT, when we will do the strings translation, when we will do the code freeze. We have to rework on each and every aspect of our release cycle. But we did it, and we did it when pandemic was in full swing. This is a testament to the dedication of our team members. One tip regarding releasing the product is, no matter how good your release and deployment process is, or no matter how confident you feel about it, always have a rollback strategy. Architecting a cloud-native system that can withstand the pressure and scale up quickly as per the load is essential for the popular product like StoryMaps. Some of the important tips to serve large traffics are: first, identify correct way to serve your static versus dynamic resources. Static resources are better served from object storage like AWS S3 or GCP Cloud. For dynamic content, you have a variety of options, from simply renting a machine in the cloud or to build a microservices architecture using containers or Kubernetes, or just deploy your code serverless like AWS Lambda or Azure Functions. Spend some time to identify pros and cons of each approach, but keep in mind to segregate your static versus dynamic content. This way, it is more manageable and scalable as well as cost effective. Second is caching. Caching is your best friend, but use it wisely. Set correct cache headers for static and dynamic content. Incorrect cache headers can serve as stale content to users or might run user into an error condition. Using CDN is must for web apps which have wider audiences. CDN providers like Akamai or AWS CloudFront are a quick way to increase the performance by reducing the latency. CDNs do it by edge caching, that is, caching your files close to your users across the globe. If you have content that changes periodically, then you can manage it through CDN caching behavior, or you can use CDN's cache busting mechanism. Third is autoscaling. If caching is your friend, then autoscaling is your savior. Setting correct autoscaling rules is crucial when you get spike in the usage. It also very helpful to keep your costs down when there is not much traffic coming to your website. Last but not least is monitoring your application. So monitoring your application vitals along with your infrastructures is important. Apps vitals like response time, error rate can identify the issue quickly than traditional CPU or memory use monitors. So set up these monitors and use tools like Grafana to create dashboard and get meaningful insight. To summarize, I will say fault-tolerant and self-healing architecture with a CDCI pipeline is key for running a DevOps for large-scale web application and a get a sleep at night for DevOps team. I hope I can inspire some of you to use these practices in your application or in your team. Thank you. Back to you, Stephen.
Thanks, Anikit. Hopefully today's presentation gave you a much better idea about what it takes to build a large-scale application like StoryMaps. As you have seen, we have an extremely talented team of engineers. We're using the latest technologies and best practices to deliver a beautiful product to our customers as fast as we can. We hope this inspires you to create new applications or enhance existing ones in new ways that will engage the world around you. But if you are looking for a new opportunity, we always have openings on our team and are looking for talented individuals who can take StoryMaps to the next level. And with that, I'd like to thank you for taking time to listen to our session and hope you have a wonderful day.